Very good afternoon, class. In the last lecture, we discussed the session layer, all the responsibilities and functions performed by the session layer. Today in this lecture, we'll be doing the next layer, which is upper to session layer in the OSI model, that is your presentation layer. In this chapter, we'll be discussing all the responsibilities and functions which are being performed by the presentation layer. Few functions are translation, encryption, decryption, authentication, compression. We'll be discussing all these in very much detail. Firstly, starting with the first responsibility or presentation layer, that is translation. As discussed many times before in the class, translation, what is translation is that, for example, if we take the today's live example, there can be two people who can communicate in different language and they cannot understand their language. Suppose I speak English and you only understand Hindi. So we need a translator between us that will convert my English speech to Hindi so that you can understand it. Similarly, while communicating, a sender and the receiver can understand different languages, so we need a translator in between. This is the main function of the presentation layer, that it do the translation process, right? For example, if one of the machine is using ASCII to store the information, the other can be using EBCDIC code. So there is a need of a translator to convert this ASCII into the language which is being understood by the receiver. Translation methods are basically, there are two types of translation method, direct and indirect. Coming to the direct method, what you do is, if the sender, for example, is using ASCII code, it sends the data in the ASCII only. At the receiver end, you have a converter, a translator, which will convert ASCII into EBCDIC code, which is being understood by the receiver. At the receiver end, it is being converted. Indirect method is that you follow a standard language, a standard pattern. First, the sender converts the ASCII to the standard. So this is the ASCII to standard converter done at the sender side. This standard format message is being sent. At the receiver end, sender to EBCDIC converter converts the language which is being understood by the receiver. We generally don't use direct method because there is a disadvantage of direct method, that if a computer is communicating with several other computers which understand different languages, so you need to maintain the conversion table for many languages. So it is not being used. We prefer indirect method. Let's come up to the next responsibility of the presentation layer, which is encryption and decryption. I hope you all guys have hear this word many times in day-to-day life, because this is used in everywhere, that encrypted data, encrypted messages. What do we mean by encryption is that the information security is the major issue these days, that you don't want your message to be read by some sniffer or some thief in between. So what we do is, we don't send our message in the original form, we can convert it. Suppose in the military area, this is information security is very important. If you are sending some important information against the enemy, and if they hack your system, they can easily make out what is your plan. So the military information is sent in the encrypted form. Encrypted form means, if you have written cat, you will not send cat in the same form, CAT. You will use some other words to encrypt cat. That this is your encrypted text for the cat. This encrypted text will be sent out via the network. If somebody is sniffing, they will not be able to make out what the sender is sending. Then at the receiver end, that encrypted message is de-encrypted by the receiver. It is the reverse process of encryption. The way you converted cat to the encrypted message, the similar way the encrypted message will be decrypted to the plain text, right? So let us come up to the details of this encryption and decryption. What we do is, encryption means the sender transforms the original information to another form and sends the resulting unintelligible message out over the network. Decryption is exactly same, the reverse process of encryption, to transform the message back to the original. So the important keywords here is plain text, your original message, encrypted text, encrypted text, the text which is being converted from the plain text. For this conversion, you need encryption algorithm and decryption algorithm, and also encryption key and decryption key. We'll discuss in detail these encryption decryption keys. What are these is, if you look at this diagram, the sender has a text to send, the plain text, the clear cat word being written. What you do is you apply some way of encryption algorithm, some sense of algorithm. We'll discuss various algorithms which can be applied on to encrypt a message. Suppose you have applied any algorithm using an encryption key. KE tells you encryption key. With the help of these two, you have converted plain text to ciphertext. Now this ciphertext will be sent over the network. So if anybody will be hacking your system, won't be able to understand it. Then at the receiver end, you have a decryption algorithm, which is reverse of encryption algorithm, and a decryption key similar to encryption key. Using these two, you convert the ciphertext to plain text, which is being read by the receiver. This is the whole process of encryption. Now we will be discussing various encryption techniques. Various encryption techniques are, we have basically divided it into two basic methods, conventional method and public key method. Today in this lecture we will be focusing only on conventional method. In the next lecture we will be discussing public key method. What is conventional method? In conventional method, the keys I have told you previous, encryption key and decryption key, are the same. Mean, suppose the key is 3, number 3. The decryption key will be also 3. It is same with the sender and the receiver, and it is secret. That means it is not being shared by anybody else than the sender and the receiver. We'll divide this conventional method into two types: bit level encryption and character level encryption. Character level means, suppose you are sending word cat, C is a character, A is a character, T is a character. So character by character you are encrypting the text. Bit level means ASCII of C. One bit of that is known as bit level encryption. Let us start with character level encryption. Encryption is done at character level. I have told you CAT. First on C, then A, then T. The two methods are there to do this character level encryption. We have done a lot of types chart. Please make it like first encryption decryption divided into conventional and public key method. Conventional is further divided into bit level and character level. Character level is further divided into two, substitutional and transpositional. It is not at all difficult, as the name tells. Substitution means you are substituting some character with other. Your plain text will be substituted with some other character. That substituted text will be now the ciphertext, which will be sent over the network. So there are two methods to do substitution. One is monoalphabetic and the other is polyalphabetic. That means mono means single. So you are replacing each character by a single. Suppose A is being replaced by D. So everywhere A will be replaced by D. Polyalphabetic मतलब A के लिए replace करने के लिए you have multiple characters. So A somewhere will be substituted by D, somewhere with E. So depending on the algorithm, we will decide how we are substituting it. Clear? So substitution method we are discussing two, mono and poly. Let's start with the mono. You will get more clear picture with this example. Monoalphabetic substitution is also known as Caesar cipher. In this, each and every character is replaced by the other character. Suppose, basically in this algorithm I mean is encryption algorithm, which we were applying on the plain text. You add some number and the same number is subtracted in the decryption. I told you earlier, encryption algorithm and decryption algorithm are reverse of each other. So if you are adding a number in the plain text, at the decryption side, you will subtract that number from the ciphertext. For example, the sender wants to send dear friend, right? This is the plain text, easily being read by human readable codes are your plain text. You apply an algorithm, an encryption algorithm in which encryption key is 3. So you add key. That means 3 number is being added to each and every character. D is your, after D you will add 3. E is your first, F is your second character, third character is G. So here you can see ciphertext first character becomes G. Then is your E. If you add 3 in E, first F, then G, then H. So E is replaced by H. Similarly, A, the third character after A is B is your first character, C is your C is your second character, D is your third character. So now it comes D. Similarly, R is replaced. In this manner, character by character, you are replacing the plain text into cipher. So this is a character level encryption. I hope with the example you are clear. And this is a substitution, that you are substituting each character with a different character. D is substituted with G. So you can see here 3 places D is there. 1, 2, 3. On all the 3 positions you have replaced it with G. So this is mono-alphabetic, that each character is replaced by with the same character. Now looking at the receiver end, same decryption algorithm is used reverse. If you have added key, you will subtract key, and the key will be same. Encryption and decryption keys are same. As I have told you in conventional method, these are same. If this is 3, this is also 3. Now you will subtract. G में से 3 subtract करोगे तो क्या होगा? F, E, the third is D. In the same manner, receiver will now be able to read the plain text. This is your mono-alphabetic, but there is a disadvantage in this mono-alphabetic, that easily the snipers get to know the occurrence. With the occurrence of character like G are same, so they can make out the positions with the natural frequency of the characters. You can easily decode it. This is not a foolproof encryption method. So we'll be doing polyalphabetic. Polyalphabetic means that a character is being replaced with multiple characters. It is not that D will every time be replaced with G. D can be replaced with E, F, G, etc. depending on the occurrence of the character, right? There are 2 methods to do this. Let us discuss the first technique. First technique is to find the position of the character in the text and use that value as the key. What do I mean by this is, now here look, we have written key as position of the character in the text. This is my text. Position of the character D here is 1. That means D mein you will add 1, so it will become E. Now here in dear, this E is at position 2. So in E you will add 2, so it will become F, and second is G. So E will replace with G. A is your third position. So you will add 3 in A. When you add 3 in A, first B, second C, then D. So A is being sent as D. Similarly R. Now you can see this D is at a different position than the first. So the key changes. Earlier you were sending D as E, but here you are sending D as J. In this manner you have done the ciphertext. Similar reverse process will be done. You will subtract the position. तो E में से 1 माइनस करोगे D, G में से 2 माइनस करोगे तो E. In this way you receive the plain text. Still this method is not foolproof method. The disadvantage is that you can easily make out the order of the characters here. Like there is only a difference of 1. There is a difference of 1. क्यों? क्योंकि यहाँ पे एक ऐड किया, यहाँ पे एक ऐड किया. ऐसे you can make out. So experienced sniper can easily break out. It is not as easy as mono-alphabetic, but still it can be made out. So we will be using a second method which we will be discussing in our next lecture. Thank you.